Let's give people a few seconds to connect here.
Yeah, I was about to say, Andrei, I see a lot of people still joining, so I just want to give them a second. But it's also a big one, this one, so it's going to be interesting, I'm sure. Lots of pressure on Valentin's shoulders.
It's not actually often that we get such a technical speaker on the session, so that's why we want to make sure everything is good. So Gabriel is saying all good. I'm not a robot. That's good. Ilani is sending salutations from Canada. Ian from Yorkshire in the UK. Gabriel from Argentina. Josef, not an AI, connecting from the Czech Republic. That's good. That's good, guys. Jasper, not a robot, just an IT guy. It all starts from IT, right? Yeah, guys. So until everybody gets in, let's actually open a poll, which is quite interesting. Hi, Julia. Welcome to the session. So the poll is saying something like this. Do you think AI will take over the world? And the options are, nah, we're safe. It might, we need to see. Yes, oh yes, the Terminator movie is a prophecy. Let's see how people see this. Okay, we still have people connecting, which is very good. And the results of the poll are quite interesting. Okay, Jens is coming in the chat and saying all good, just a curious participant from south of Spain. How is the weather in the southern area of Spain? Jens?
I'm sure it's going to be great, Andrei. It's never really bad there.
Yeah, that's what I'm thinking about as well.
But they would probably like some rain from time to time.
Okay, let's close and share the result of the poll, and let's see what our audience thinks about AI right now, because we're curious what you're gonna think about AI at the end of this particular session. So we have the winning class. It might. We just need to wait and see. Then we have the second response as volume. We're safe. Third response as volume. Terminator is a prophecy, and the last response, it's just a pure yes. It is gonna take over the world. Let's actually hope that we can make it take over just a part of the world that actually is made to help us and not actually hinder us. Now, with that being said, ladies and gentlemen, let's actually proceed because we have a lot of information for you today. The topic of today's session is AI and its role in future-proofing malware and email security. Now, just to do a quick round on the speakers, the majority of the people joining the sessions might already know me. My name is Andrei. I'm the Cybersecurity Solutions Expert here at Heimdal. And my credentials are over 5,000 cybersecurity meetings and just shy of 1,000 implementations. I am joined by the main speaker of the session, Valentin Rusu, which is the head of AI at Heimdal, and I'll pass it to Vali to introduce himself.
Hey everyone, first of all, thank you for joining us today. Well, as Andrei said, I'm the head of AI at Heimdal. Well, I am the one in charge of analyzing the state of the art in the industry. So I should analyze the competition, the latest development, all the articles about AI in cybersecurity, and all the research that happens in cybersecurity. And my team is the one that is trying to make the impossible possible. So we are the ones that we are trying always to implement the latest developments and try to improve our products near to the state of the art and also beyond.
Thank you, Vali. And now we're going to pass it to our CEO, Morten, to do a short round of introduction as well.
Yeah, good to meet everybody, and thank you for joining the call today. I think, as Andrei said, Valentin is the real rock star on the call, and will be doing the main part of the speaking. So I'll keep it short. But my name is Morten, CEO and founder of Heimdal back in 2014. I'm happy to be with all of you on the call today, in our hopes and and dreams to build this into a global cybersecurity business. We are today Europe's largest organically built cybersecurity business. So thank you for your support. And we, as we will show on this call, I think we try to continue to deliver on that.
Okay, so Mr. Morten, would you like to do a short speech on the disruption attitude in cybersecurity rather than just improving on what is right now?
Yeah, for sure. I think a couple of things here which has been really interesting, and let me start with a small backdrop story. So if we look at Heimdal, kind of go back to 2014, Heimdal was a point solution innovator at the time, so a small local Danish brand focusing on DNS and patch management, evolving that into today where we have the widest suite of products in the cybersecurity industry. We've then since also doubled down on the AI space. And that journey has been a journey of continuous innovation, leading in front of the market, which a lot of people on this call might not know, but Heimdal was the first vendor ever to focus on the ransomware subject. We ranked #1 on Google for quite a good chunk of time on ransomware back in 2016. Coming into then 2018, we were the first vendor to launch a firewall kind of protection capability for brute force attacks, going up to, I mean, lots of recent enhancements around other subjects today. But I think the most epic milestone of late is when we launched the what we call the Threat Hunting and Action Center, which is the first kind of unified portal for, I'd say, cybersecurity management across the board. Which is also a real innovator. And then, of course, delving into the AI topic, that's been something we've been focusing on quite heavily for the last 3 or 4 years. We have 2 patents out already, one for the DNS, where we use the first algorithm in the world to use what we call predictive DNS. So we rely on AI to predict malware coming tomorrow or the day after, or also what existing the domains are changing today, but then also leading into email fraud and kind of more heavily the general malware area, which I'm sure Valentin will also touch on today. So if you look to that and then kind of spin it into this kind of phrase we have on the screen, I mean, it's clear for us that to move from being a small player to being certainly a pan-European player today, we're looking to be a global brand going forward. We have to continue to disrupt the market, and as it kind of neatly says here on the quote, yeah, you don't do that for just persistent improvement of the postcard. You don't get to the telephone by doing persistent improvement of the postcard. But then similarly in cyber, you don't get to kind of innovate a certain chunk of the market if you only focus on doing what everybody else is doing. You have to move outside the box and be quite disruptive, which kind of, as I alluded to before, I think we've been a number of times, and is what we're trying to be again here, or what we're going to try and walk you guys through as to what could be coming in future with Heimdal.
Thank you, Morten. I'll pass it to Valentin because I know that you guys are eager to hear what we have to say on the AI space. So Vali, whenever you want to share the screen and start the presentation, and again, just a fair warning for the audience, grab your favorite drink. This is going to be quite an interesting one, and Vali will even help you create your own cybersecurity startup, if I'm not mistaken. But again, I'll pass it to him so that he can steal the show.
Okay, first of all, can you see my screen?
Yes, we see Valentin.
So, okay. Well, first of all, today we're going to discuss about 2 topics. We're going to discuss about malware detection and malware security, and also about email security. And we will see how we can improve those products using artificial intelligence. So let's start with the first one, with the malware detection. And this is the game that I want to propose. Today, you're going to be the CEO of the company, and I will be the technical lead. And together, we will build a startup and machine learning based malware detection company. And we want our technical solution to be among the best 10% of the companies in the world. And in order to do that, we need 5 steps. We need to implement 5 algorithms, and we'll go through each of them, see the challenges, and see where you can apply artificial intelligence into those algorithms. So let's start with first one, signature-based detection. Well, signature-based detections were the first algorithms implemented in antivirus, and they were so good that we are still using them today. We still use this algorithm. And how it works? Well, first of all, in our fictive company, we're going to employ a team of malware analysts, and also we're going to have a team of developers and a team of AI engineers. And you will go to the team of malware analysts and ask them, okay, guys, we have a data set of malware. You need to extract some signature, some features from those malwares and store them in a document, in a file, in a document called VDF, Virus Definition File. We're going to send those files to each of our customers. And we still use this approach. We send them every hour, I believe. And in those files, we will have in one of the columns the malware pattern, even if it's a malware name or a CNC or a category of malware. And in the right part, we will have a part of the bit structure, a part of the bits of this file. This is as easy as it can be. We're going to send them to all of our customers. And when on the computer, on the endpoint of the customer will be on a read or a write process, we're going to compare all of those bytes. And if you see those bytes in the write process, we're going to quarantine the file and stop the process. And this works very well against mass campaigns. So for example, if there is one malware that will be spread to 1 million people or 1 million endpoints, this works very well in detecting them. Well, it has a problem. It has a limitation. Hackers can easily modify those patterns, can easily modify this byte structure. And also, the file will become very large, and it's very hard for us to send them to all of the computers. It will take a lot of resources and a lot of money. So we need to implement another system, a file reputation system. And how this works? Well, for each file, we will create a unique identifier. You will use a hashing technique using MD5 or SHA-256 that will give us a unique ID for each file. It's like a personal number, something that only that file will have. And you're going to put all of those unique IDs in a database and send them to our customers. And in this database, for each file in the computer of the customer, we're going to read this unique identifier. If it's in our database, then you're going to delete it or quarantine it. But this has a limitation, and you will see immediately why. Let's imagine that we have those two files. We have this document. This is a simple document. This is a cool document. The only difference between them is only one word, simple and cool. Well, imagine that we have this file in our database. We have the MD5 for it, and we know that this is a malware. The attackers, the hackers, can only change the word, and they will generate a new and completely MD5. So this is the limitation of this approach. If they're going to change only one word or only one variable in their code, they're going to get a new hash, and they're going to trick our system. And you might ask me, okay, but there is nothing we can do. We can't find the similarity between those files. And there is an algorithm called fuzzy hash. It's a hashing system that takes into consideration also the similarity between those files. But still, this has two problems. You can't use them in production. One of them will be the computational power need, because remember, you should work on the customer endpoint. So if one of our customers presses double click on a file, and if it doesn't open in the next 1 or 2 seconds, they're going to call us. Guys, there is a problem. It's working too slow, your algorithm. And also, we can end up with 2 files on the same hash. But until now, we can only make an if-else system. We can compare those fuzzy hashes, and if they are similar, we can assume that they are similar files and similar problems. Still, there is a more accurate method to do it using machine learning. And using machine learning basic algorithms, we don't need a lot of computational power to do it. We're going to take all of our database and extract features from it. In this way, we can cluster our database in malicious files and clean files. And when you're going to have another sample, you're going to measure the distance between this sample and the categories. And if it's closer to the malware files, it means that this is a malicious file. And the question is, how do you draw this boundary? Where do you know that it's starting to become the malware class and the clean class? And in order to understand this easier, I'll do a reference to computer vision. Let's suppose that here in this cluster, we have cats images, and in this cluster, we have dogs images. And also, I want to make sure that everyone understands in machine learning, when we say features, those are actually characteristics of the object, characteristics of the malware file or characteristics of the image or the object we want to describe, like shapes, colors, everything you can extract, every information you can extract from that object.
Well, can I just cut you off, Valentin, very quickly?
Yeah.
So I know and sorry, me and Andrei turned the cameras off. We just want to make sure that everybody's firmly paying attention to Valentin. We are here and listening. But I would just like to say, given the very technical nature of this, if people have any questions, I wouldn't hesitate to ask them, because me and Andrei can happily cover off some of the questions whilst Valentin is talking. But I think it's quite important to understand the complexity here and how this actually benefits you as a customer and our customers as a whole, because it's quite technical, but I think Valentin is doing a good job of keeping it low key. But again, any questions are more than welcome. I think the importance of understanding is quite key. Sorry, Valentin, go ahead.
No worries.
And we do have
also,
feedback from the audience. Sorry, Valentin, we do have feedback for the audience. It's good. Keep on. You're doing a great job, Vali.
Thank you. And also, we're going to have another session in 3 hours. If there is something you need to understand a little bit better and go into more details, we are waiting for you also in the next session. And also, we're going to leave our email addresses. Don't hesitate to contact us if there is any question remaining after this webinar. Okay? Okay, so let's move on. As I said, we have those characteristics, those features, and we need to define how do we set the boundary between cats or dogs, between malicious files and clean files. And you can say, okay, if it has mustaches, it's small stature, small ears, then it's a cat. And if it has a lot of fur, it's big, a big tongue, then it's a dog. But what happens in those cases where you don't know if it's either a cat or a dog, it's in the middle? Well, this happens in malware too, in our analysis too, because we have clean files, clean applications that act as malware, and those are in the middle. It's very hard to draw the boundary between them. So most of the cybersecurity companies, they will move the boundary as close to the clean as possible. And in this way, they might have false positives, but they don't risk saying that something infected is clean. So they are assuming multiple false positives. But we, in the startup, in the fictive startup that we're inventing, we have another approach. We have something better, and this is called FAIS. Well, FAIS started actually from Anoi. Anoi is a software developed by Spotify to find similar songs for their customers. And they build a collection, they build a database of features, of characteristics. And this looks like that. This is the algorithm that I'm describing is actually FAIS, is from Facebook AI research. Well, you can have a collection of images, and for each image, you're going to extract multiple features using a convolutional neural network and put them in a vectorial way. For example, those 3 vectors might be the arm of the square. Those 3 might be the white spot from the chest. Those 3 might be the yellow color and the shape of the smiley face. And we're going to put all of those features in an indexed database. And when you're going to have a new image, a query image, you're going to transform it in a vectorial representation and do a mathematical difference, a statistical difference between this object and all the objects in the database. And here are the results. Let's see the examples. When you're going to query this image, it's going to return images from this category, the similar images and their scores. And as you can see, this is a dog image because the results are from the dog category from our data set, from our database. And this happens in Malware too. We have a file, we don't know anything about it. We're gonna query the feature database, the indexed database. And if the response will be only from the ransomware category, we can say that this is a ransomware. It's very similar to a ransomware. And this is the smartest and more complex way to do things. And okay, so far we have databases that we send to our customers, and based on that, we discover malwares. So we can start selling at this point. The problem is that one of our customers might ask us, okay, what happens if you don't have the file in the database? How do you do the protection? And this is called in cybersecurity real-time protection. Real-time protection has two categories: static analysis and heuristic-based, behavior-based analysis. Now, for static analysis is the analysis we do without seeing the behavior of the malware, without running the malware. Only by seeing the details, by pressing right-click on and details, we can determine those 1,000 features. There are actually a lot of features and characteristics you can determine, like the MD5, if it's signed, the company that signed it, the byte entropy, the size, virtual addresses, paths. There is a lot of information. And we can go to our malware analysis team and tell them, okay, you have a very big data set, you have millions of files, of malicious files, and you have all the data about it. Now, can you create an if-else system? Can you create a system in which you manually label all of those malwares? And they will create something like that. Okay, based on the data that I have, I know that if it's an unknown MD5, it's not signed, and it has a small size, this is a malware. And this is how 50% of the companies are doing. And from my point of view, this is a mistake because it's more like a guessing system. It's very prone to human error. It's not something based on statistics and based on data. And I think that in science, we need to have things based on the actual parameters and based on actual data discovery. But there is a very easy and simple machine learning algorithm that can be used for this part, in which way you can discover the data set and do the metrics based on a statistical approach. And this is called tree-boost neural networks. There are multiple variants, and I'm going to present you only one of them, called the random forest. And why it's called the random forest? Because it creates multiple smaller trees. It combines multiple features, multiple of those columns, combines them together, and creates hundreds of those smaller trees with combinations with hash, byte entropy, signature and size, signature and paths, and so on. Multiple smaller trees. And with those, so it's going to create multiple smaller trees in multiple variants. And with those smaller trees, we're going to take a test data set, a data set that was not seen before by the neural network, and use it to categorize all the files in the data set, in the test data set. And let's say that for the first sample, we have 100 smaller trees. 90% of them will tell that this is malware and 10% of them that this is clean. Well, we're gonna sum all of those errors and accuracies, and in the end of the algorithm, we're gonna measure the error of the system. After we measure the error of the system, if the accuracy is not good enough for us, we're gonna try again and again, creating new subsamples, new more random trees, more simpler trees. And based on that, we can measure way more precisely the accuracy of our data set and of our solution without creating a very complex if-else system that we don't know how it works. Okay, so guys, there is actually a more complex way to do static analysis, but this is only for the top companies. As I told you, we want to be among the best of them. we can make this problem as a computer vision problem. So this is the bytes of our infected files. We can cluster them and try to create a map of pixels and features. And in this map, we'll end up with an image that looks like that. Well, this is actually an image of a malware that we have in our dataset. We can use this image in a convolutional neural network, in a binary classification network. Those convolutional neural networks are very complex, and it will take me a while to explain what is inside here. But you need to understand that this is kind of a black box in which you feed it with a lot of data. It adjusts the parameters inside the box, and it will be able to tell you if this is a malware or clean sample, or I don't know, if it's a dog or a cat, any type of data you're going to give it, or class. Let's say that for this input image, we're going to get which we know that this is malware. We previously know that this is malware. We're going to get the result that this is clean. Well, we're going to put the neural network train again and give it a penalty for the miscalculation. Based on this penalty, it's going to adjust the weights, and based on the weights adjustment, it will end up with the best accuracy possible for the given dataset. And this is where we end up the static analysis. So right now, we have static analysis, we have database analysis. We can easily go on the market and have success. But as I told you, we want to be among the best. So let's move one step forward. Well, we can take our malware analysis team and give them a sandbox. A sandbox is a control environment where we can run ransomware, we can run all types of malware or clean files. The output of a sandbox is like a complex VM. This complex VM will tell you what the samples does inside that computer. And for us, this will be an output. It enumerates all the running processes, which is not very suspicious, installs itself for auto run at Windows startup. This is a little bit suspicious, but very suspicious that it clears Windows event logs and attempts to delete or modify the shadow copies. The shadow copies are the Windows systems for backup the data, to recover the data. And this is ransomware behavior. They need to delete those shadow copies, otherwise you can use this backup and there is no point for them in encrypting the data anymore. So this is actually a ransomware behavior. And we can ask our guys, okay guys, we have those behaviors. Try to create some metrics that we can put to our customers, some heuristics. And now we Heimdal, not our fictional startup, we have 3 of those products. You use heuristics in antivirus, and you have them in 3 levels, from informational to critical. You use it for our ransomware encryption protection algorithm, REP, which has rules specialized only for ransomware detection. And you use them in extended threat protection, XTP, which is a product used for CM and SOC team, by the CM and SOC teams, to analyze what's happening on a computer for a real-time detection and real-time analysis. And how those work? Well, based on what we've seen before, our malware analysts wrote the rules for each of the possible scenarios while running the actual file on a computer. We check all the logs, and based on those logs, we discover if one of the rules have been triggered. And those rules are, for example, for what you've seen before, for clearing Windows logs, deleting shadow copies, and based on them, we discover if this is a malware behavior or not. Okay, here you can have 2 problems, and as you can see, high false positive rate, because those are not actually false positives. What is the problem here? There are a lot of applications, not so well written, that mimics the malware behavior. And I'll give you an example. Almost 2 months ago, we had 1,000 detections for one of our products at one of our customers on XTP for data exfiltration and ransomware. Having so many detections, it escalated very quickly. We called the customer, entered in a session with him, isolated the machines and everything. And it was actually a legit application. It was actually a support ticketing application that had the following behavior. It read all the logs from the computer and sent them to, and also all the data, it screened all the events in the computers and sent them to an unknown server, unknown by us. And we asked the customer, did you know about this behavior? And he told us that he didn't know. And we set up a call with the production company, the ones that produced that software. And we asked them, guys, what's the problem? Why do you need this data? And they told us that they are using it in marketing campaigns. And naturally, I asked them, guys, this is a privacy violation. It's not normal to use this type of behavior. And they told us that they know, but it's written in their contract, it's written in EULA, so there is nothing we can do about that. So those are the applications that give us false positives, the ones that are acting like malware. For example, on Monday, we had another case with an application, a wallpaper application, that used to take all the images from your computer, encrypt them, and put them in temporary file. This is actually malware behavior, ransomware behavior. And we didn't know why they're doing this, but it is what it is. So this is why we might end up with some false positives in those areas. And moving on, there is another problem with this approach, but this time for our startup. Since I told you that we are building a startup, in order to build those heuristics, we're going to need a lot of malware analysts. We know a company that has 200 malware analysts that only extract heuristics and populate those databases with signatures and file reputation systems. So we're going to need a lot of malware analysts. And since we are a startup, we need to find a new innovative way of doing it. And there is a way. Well, you remember the sandbox, the safe environment? What about taking all of our data set and let it run in sandbox for 2 minutes, for example? And after that, for each sample, we're going to extract the logs and try to categorize them by event IDs. It's not a manual work, you can do it automatically. And try to extract embeddings. Embedding layers is the vectorization of the features of the categories. It's like in the for example, in the dogs and cats example. And based on those embedding layers, we're going to let an LSTM layer, which is a long short time memory layer. It's used in convolutional neural network most of the time and in time sequences. Don't bother about the name. We need to remember that those are temporal sequential layer that are learning a temporal sequential type of data. And this one is going to output us if it's a malware behavior or not. To make it easier to understand, imagine that we have this result from Sandbox. We're going to have a timestamp for each of those logs. And if they follow this order in less than 30 seconds, we can say that this is automatically say that this is a malware behavior. And the neural network will learn to act as a malware analyst. And in this way, we can write our heuristics without needing 200 malware analysts. This is a very good idea. It's a very complex idea that works perfectly fine. It was tested by us, but still it has a problem. And this is the 6th step. Remember that I told you that there are only 5 steps where there is a 6th step. The problem is that you can't use it in production. Those are the adaptive algorithms, like the ones seen before. Adaptive algorithms are actually state-of-the-art detection mechanisms. The problem is that they have a colossal computational expense cost. In order to put those in production to our customers, you're gonna need supercomputers for all the customers, and the cost will be colossal.
And just to be clear, Valentin would love this stuff, but it's the bold CEO from Scandinavia that tells him that doesn't work. We need to find something more cost efficient.
Yeah. And guys, now we can do a recap of the malware analysis for our startup company. Right now, if you implement all of those algorithms, I can promise that we are going to be, from the technical point of view, among the best 20% of the company on the market. So we're going to need the classical signature and file reputation patterns, followed by an enhanced with file similarity neural network or something more complex with FAIS or ANOI. We're going to need a static analysis tool, either an if-else system like most of the market or something more unconventional like tree-boost neural network or convolutional neural networks. And you're going to need sandboxing and heuristics that can be either extracted by malware analysts or a malware analysis neural network. And in this way, I can promise you that you can be among the 20% of the best companies in the market, because there is no one that knows competition better than us. We are ready to sell. How do you sell things? That's Morten's specialization. So she's going to have a webinar of how it is to be one of the CEO of one of the best companies in cybersecurity. So don't forget to follow this one. But from the technical point of view, that is all you need. Okay, so we finished the malware security and malware detection part. Let's move on to the next step in our presentation, the email security. Well, this is going to be a different type of presentation. We're not going to play some more. We will show you the challenges and our two main products for email security, why we need them, and why we created them in the first place. So let's start with the challenges. Well, there are 347 billion emails traveling every day. So you can imagine that there is a very big diversity here. Returning to our computer vision example, imagine that you have 347 billion kittens and little dogs every day. It will be almost impossible to draw the line between them. What's a dog and what is a cat? And this is happening in email security too, because since there is a very big diversity, we can have malware campaigns, spam campaigns, spear phishing campaigns, marketing campaigns, newsletters. It's very hard to distinguish what the customers want to see and doesn't want to see. And this is a big challenge right now, because also if you go into your inbox, I can bet that you have, I don't know, like 20 subscriptions to newsletters, and maybe out of them, you only want to see one of them. So for us as a cybersecurity company, we don't know what you want to see and you don't want to see, and it's very hard to draw the line. The next big thing is social engineering, and there is a quote that I really like. Why break down the wall when you can ask people from the inside to let you in? Well, we understand that it's our job to be cybersecurity experts, and not everyone has to be a cybersecurity expert. But we want to make everyone aware of the risks of cybersecurity, and that the internet is not a very safe place, and you've seen the worst of it. We really seen everything that could possible imagine, and also that the hackers are very professional, very good computer engineers. So don't try to play with them, because they are very, very good in what they are doing, and they have a lot of them, or a lot of time. Which leads to the third problem, targeted attacks. Well, hackers right now change the paradigm. Instead of creating a mass campaign, creating one malware that sends them to 1 million people, they change the paradigm. They study a company and try to tailor a solution or try to break in only one company. It works better for them and it's more risk-free. So with that in mind, I ask a general question. What makes the perfect email security system? And maybe it will be nice if you can answer us in the questions, or I don't know where you can answer it. But I can tell you what we believe to be the perfect email security system. We analyze this problem, and we believe that it should have 24/7 email service availability. It should have protection at its core if it's our main objective and our main purpose to create security products. And it should have optimized performance to get your response as close as real time as possible, because if you're going to get your email after a few hours, there is no point in doing it anymore. And with that in mind, we created our first product, Email Security ATP, which from my point of view is one of the best, if not the best on the market. It's genuinely an amazing product. And I'm going to tell you what it's in the core of it. We have more than 1,000 security layers that analyze everything possible in an email. We analyze the attachments, what is written inside those attachments, the language, the sender, the subject, how well known is the sender, the IPs, everything you can imagine, and even more. I think that to present this product, I need more than 2 hours, and it's going to be only the tip of the iceberg. It took me a very long time to understand all the layers in this product. It's very, very complex. And even more, to help customers a little bit more, we have an easy setup for this product. So we help our customers set up the MX and also the domains in order to work with our product. And it has a very nice interface where you can adjust all the layers of security for your company. And now, since we have this perfect solution, you might ask, why isn't this enough? Because we have the perfect wall, the perfect shield, no one can penetrate it, no one can enter in our citadel. What is the problem with it? And if you remember from malware detection, there are some accepted risks. There are some applications that are not very well written. And the same happens in email. It's very hard for small companies to adjust and to configure their email system. And our customers need to interact with those companies. And we had a case a while ago for a customer that asked us to remove the TLS and SPF layer. And just to imagine, the SPF and TLS layers are those for signature and encryption. And naturally, we told them, why would you want to do that? Because it's like writing your emails on Facebook. Everyone can see what's inside. And they told us that they are aware, but they are working with another company that don't have the right setup for their email system, and they can't lose business because of the security email. Which leaves us to the next problem, that standard security is too rigid. In order to have all the security layers up, it's going to be a rigid system. You might lose some of the freedom. And also, there is the third problem, which is related to the targeted attacks. Sophisticated malware-free attacks. What are those? Are those CEO impersonations? Let's imagine that Morten is going to lose his laptop today, or maybe he has a weak password, or someone is going to hijack his email security.
Hey, Valentin, I don't have a weak password, you know.
Yeah, I'm sure about it. Let's imagine that the CEO will have that. Well, what about if you're going to receive an email from the CEO of the company asking you to, I don't know, to pay a bill, to pay this invoice? And it's a legit email, so no security system will detect it because it's an actual email from the CEO of the company with his signature, his email system, his SMTP, everything. You might ask, okay, it will never happen to me because I will double check with the CEO of the company before paying the bill. But I have to tell you that everyone can be a victim of spear phishing, and you've seen a lot of innovation here in this area because they're going to use a personal touch before that. Before sending the email, they're going to ask you something like that. Hey, Valentin, how are you? Do you feel well today? How was your holiday? Is your wife okay? Well, when you're going to return from holiday, please pay this invoice. And when they're going to use this personal touch, everyone can be victim of spear phishing, trust me. So we decided to change a little bit the paradigm. Okay, let's not look anymore into malware. Let's look at the company. Because right now, all the security products on the market, they are focused on the malware. There is always a fight between us and the hackers, never ending. We innovate something, they innovate something, it's a never ending fight. So let's move our paradigm and let's look at the company. It's like having a one-to-one discussion with each company and try to create a personalized solution, a tailored cybersecurity solution only for them. And you will see that a company based on sales or on digital marketing will have different needs from the ones from the pharmaceutical or, I don't know, the travel industry. So let's do an exercise. Only by looking at those images, we don't know anything about them. There are only some icons. You can see only by looking at their colors that there is something strange here. Something doesn't fit the pattern, something that is out of the distribution. And those out of the distributions data, we call them outliers, something that doesn't fit in the normality. And we thought ourselves, why not building a system based on outliers? So let's see how this will work. Well, what about taking some complex features? We take all the features that we build around our ATP, those thousands of features, all the research that we have around those email security systems. We can use some self-learning algorithms and give every customer an individual neural network. And in this way, you're going to create a new product, a new tailored solution for each customer. It's like having a personal assistant that can work 24/7, can read all of your emails, knows everything about cybersecurity and about our products, and knows everything about our previous emails, knows everything about what is the normality in your system. And then let's see those features. Let's see how it works. Well, those are only the names of the categories. There are actually thousands of features. I believe only in the HTML analysis there are like 40 of them. Let's see some of the features and discuss them. Well, we have an IBAN scanner. This is what we call a financial word system. We extract all the financial words from the email and attachments. We have a neural network for clickbait detection. We have a neural network and a database for suspicious links and domains. We have a database for each customer in which we keep all the interactions between him and other companies. We keep the timing for each of the companies. For example, the normality pattern for me will be to write emails from 10 a.m. until 7 p.m. After that might be an outlier. So we have a very complex set of features, and you put them in a self-learning neural network and send them to the customer. From this point, based on the previous emails, based on what we see in the company, those features and their weights will be adjusted based on what they see inside the company. And let's take an example with a bank company, with a bank system. For them, it's normal to get a lot of financial words because it's a bank industry. For them, it's normal to receive new emails for new addresses every day. It's normal to receive emails or to send emails at 2 a.m. because maybe someone got his card stuck in the ATM. It's normal to receive emails in multiple languages, but might not be normal to receive suspicious links, infected attachments, or I don't know, strange HTMLs, strange formats. On the other hand, for us, as a cybersecurity company, we receive everyday suspicious links, attachments, different formats. We have support 24/7. So for us, this is a normality. And if you would not receive the suspicious links and attachments, that will be a business disruption for us. So for us, the security layer for attachment analysis should be down. And this is how this neural network adjusts for each company. For example, in the marketing industry, for them it's not so normal to receive a lot of financial words like in the banking system, but it's normal to receive multiple HTML formats since it's the creativity industry. It's normal to receive emails without all the EML's features like the KIM, the mark, and so on, because they are the ones that are creating those, that are creating new emails and new addresses every day. It's normal to receive new customers every day. This is why we believe that this solution works perfect, because instead of creating one big solution, one big wall that works for all the customers, we change the paradigm. We start from the customer and adjust based on what we see in the company. And all of those can be seen in a very nice interface. Here you have the summary report for every month. You will see all the user anomalies and all the features that we talked about, the statistics, how they evolved over time, and you will understand why the neural network labeled something as being an outlier. And there are many examples to be told here. But you need to understand that this solution adjusts on what we see based on multiple features. And this is what we believe that is the best combination in email security. We have email security ATP, which is the perfect wall around the citadel, the perfect shield. There is no malware that can penetrate it. And we say that it has more than 99% accuracy, because in statistics, you can't say that something is 100%. It's not correctly true from the statistical point of view. So it has more than 99% accuracy. And we have our AI assistant that will solve all the problems for inside. We have one malware analyst, one trained malware analyst that can read all of your emails, understand your industry, and adjust the features based on your needs for the company. So guys, we finished the malware detection part, the email security part. Now in the end, I want to end up with the paradigm that I believe that the future of cybersecurity lies in artificial intelligence. And as you can see, we can combine and expand our products using state-of-the-art AI systems. Thank you. Andrei, can you take over?
Yes, can you hear me?
Very poorly.
Yeah, it's very faint.
Can you guys hear me now?
Yeah,
Yeah.
that's much better. Yeah.
That works fine.
Okay, perfect. Valentin, I'll steal the screen sharing from you. Thank
Okay,
you.
thank you.
Okay, thank you so much for that, and thank you to the audience for sending all those questions in. Very interesting questions, especially the one with WhatsApp. Exactly what Vali said, accepted risk for more availability, right? We communicate faster on WhatsApp, so that's why we want to use that. But then we kind of disable the security layers that an email system would provide us. And as Morten well said in one of the responses, then you would need to think of the defense in another way. You would need to secure the device itself, make sure that the links that you connect to and the applications that you're receiving from these communication channels, and it's not just WhatsApp, it's Signal, it's Telegram, and so on and so forth. But that was a very interesting question. Now, I would like to pass it to Morten to just tell you just a bit about who is Heimdal, which is a part that we usually do at the beginning of the webinar, but we wanted to keep this after Valentin presents to us. What do we do in the AI space?
Yeah, thank you for passing it back, Andrei, and I'll try to keep it brief so we can let people off the hook. But again, as where we started with the intro, as we kind of alluded to, Heimdal was and is a journey where we kind of started here from the left. We started doing DNS security, patch management, and kind of how to say re-engineered that part of the market and disrupted it a bit. I would say we have an incredibly scalable, as many of you on this call will probably know, incredibly scalable patch management solution and a DNS solution where I would say we do the deepest level of DNS security of any vendor on the market, providing more telemetry and more threat hunting capability than other vendors. But then we kind of expanded from there. And we're not showing it like this on the screen because that's where we started, but we're showing it like this on the screen because the way we like to show it is from, how to say, proactive to reactive protection technology, and then kind of straying into the UEM. So if you start from the left, what we do is, of course, the proactive security measures, and then as you start to move to the right, it becomes more and more reactive in general. So today, Heimdal has the widest suite in the market, as I kind of alluded to in the beginning, with these kind of super disruptive features, the threat hunting action center on the far right there, and the email security and email fraud, which Valentin also just touched on there to the right, a bit to the right. But also we allow you to do management of the endpoints and servers with the remote desktop pieces to the far right. And the really cool thing I think for a customer here is the fact that we can also overlay this with MXDR, so a 24/7 monitored SOC for you as this whole platform rolls into an XDR platform. The only thing I would flag to customers on this call is a lot of people call out XDR in the market today, so Palo Alto, Barracuda, Checkpoint, etc. You need to look at the width of the suite because again, nobody really has this kind of width of the suite. So a lot of those calling out XDR will be missing some key features in there, in my book at least, which could be vulnerability management, for example, or privilege elevation and delegation management, which they won't have, which we do offer. So if you do look at XDR, you are considering your vendor lineup, this is something you need to consider, that can you actually get a vendor that has this much technology in one place? And one of the things which we don't offer, of course, is the perimeter firewall technology today. That is one of the things we're looking at integrating into our threat hunting and action center going into next year. So you can basically manage your firewall data through our services next year. I think that provides a good high-level overview, both of where we started, Andrei, but also where we are at the moment. Anything you want me to add?
No, sir, that's good, because that brings me to the next slide, which is CEO Cyber Chat. Ladies and gentlemen, you will receive an email pretty soon with a registration link. This is the webinar of the year, because as we had one of our technical wizards in this session, we're going to have this session with one of our business wizards, which is Morten, exactly one of your hosts today. On this one, when you register, do also submit what questions you have for Morten, because we will look at what happened in 2023 from a cybersecurity industry perspective. He's going to share his predictions with the entire audience for 2024, and half of the session is going to be open Q&A. We're going to look at all the questions that you received, and I'm sure that Morten will have some very good pointers for you, regardless of the questions that you guys come with. There is also a related resource that you can download from the handouts space, which is a data sheet containing our entire XDR platform. And with that being said, we should open the Q&A space with all three speakers. But before we do that, if you want to chat some more, you have a QR code over here, which opens up a portal to book a 30-minute meeting with me. If your questions are more towards the AI space, I will make sure I vet them by Vali. If they are more towards the business space, I would suggest keeping it for the next webinar, but still I'll go via Morten and get your answers. If you just want to talk cybersecurity in general, then that's my space. So yeah, please do use the QR code. And also in the post-webinar survey, you have the space where you can share your feedback with us, and also have three options of follow-up, which is you want to book a demo, you want a free cybersecurity posture review done by me, or just a general cybersecurity chat. Okay, so let's go into the questions now. I believe we still have 2-3 more minutes. So quick question I see from the audience: what are all the Heimdal products where we have AI under them? Morten, would you like to take that one?
Yeah, for sure. And the depth of the AI will of course vary. So how we do that, and how we leverage various levels of technology in there will certainly vary. But on the DNS side, if we again started from the left there on the product lineup we had on the screen before, DNS is heavily powered by, it's actually almost solely powered by AI today. So whereas before we leveraged white and blacklists as other vendors did, today we kind of solely leverage the AI to feed the telemetry in the engine. So that's quite unique. So those are the DNS security products you see here on the screen. Then if you kind of move a bit to the right, as you can kind of sense from today's webinar, we heavily kind of re-engineered the email security piece to kind of the middle right there, and the email fraud pieces of late. So we recently put out a patent registration for the email fraud prevention as well, which now goes by company. So that's a quite unique technology that we're started offering. But then clearly going into the likes of where Andrei had the cursor before, the AV, the ransomware protection, those are kind of where you'd use more traditional behavior, heuristics, and then kind of algorithms to leverage your defense mechanisms there. But then also, if you go to the far right, then as we start rolling it up into the platform view with the threat hunting and action center, the way we compute the scores there is also algorithm based to kind of assess the criticality of the environment, etc. So there is a lot of processing power, I would say, being applied today across the estate in terms of making it smarter, faster, and doing the detection faster in your environments already today.
Perfect.
Are there more questions, Andrei?
No, not that I see so far. So, Vali, Morten, any last words for the audience right now?
Not for me, just a real pleasure having so many people on the call today, and looking forward again to the call this afternoon.
Same
Perfect.
for me.
Thank
Thank
you,
you guys for
everyone.
joining us.
And thank you to my esteemed speakers for joining today. If anybody wants to go through this again, or you want to invite someone, we have another session at 3 p.m. Central European Time. So just reach out. Have a nice one, everybody. Goodbye.